This can be a very challenging problem right here if you don't know how to handle it. It's a type of counting where you're counting up the number of ways to select people out of a larger group. This is called looking for combinations. Now there's two types of counting, two major types of counting: permutations and combinations. Permutations, we're all familiar with. What these are is these are things like the code to get into your garage door, where you could type in 1234, maybe that's your code, and that would work, but 4321 would not work even though it's the same numbers. In that case, order matters. Combinations are different. With a combination, the order does not matter. We just want to ask how many ways are there to get a certain group of numbers. So as an example, in this one, right, we've got a team of astronauts. Let's say you choose your 5 astronauts. Does it matter how they sit from left to right in the ship when they're blasting off to the moon? It doesn't matter at all, right? You got Susie, Bob, and so on. And it doesn't matter if it's Susie, Bob, or Bob, Susie. It's still the same number of astronauts. It's still the same people sitting in the ship. So what we're dealing with here is a combination. And they made that very clear in phrasing this, number of combinations. And we have a particular formula. Now, I'm not a big fan of giving you formulas to memorize because there's a lot of stuff out there, and usually I prefer to reason through stuff. But when you deal with combinations and counting, this is a formula that is worth memorizing, because trying to logic your way through the combinations is kind of tough, actually. So we're going to go through this formula and how we actually do this. I want to focus on this phrase, n choose k. Okay, n choose k. That means 8 people, in our case, that I can choose from, and I have to choose 5 of them, right? This is 5 people chosen from a group of 8 candidates. So what's the larger group size? That's 8. How many of them do you choose? That's 5. So that means n equals 8, k equals 5, right? It's n choose k. So all we have to do is plug these into our formula, and we're going to get our answer, the number of combinations that are possible. So this is going to become 8 factorial divided by 5 factorial divided by 8 minus 5 factorial. Okay, we simplify this a little bit. You probably know what the factorial symbol is. Maybe you're not familiar with it, but it basically just means you multiply by all the numbers in order that are smaller than the numbers. So this is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And now we've got 5 times 4 times 3 times 2 times 1 from that 5 factorial. Now 8 minus 5, that's just 3. So 3 factorial, I'm going to put that over here on the right. That's just 3 times 2 times 1. Well, here's the part where you might say, oh boy, that's a lot of math. But it's really not. Check out what happens. The 3's cancel out. The 2's cancel out. The 1's we didn't need to worry about anyway. Okay. I've got a 4 right here and a 4 right there. That's nice. Got a 5 right here and a 5 right there. And hey, the 3 times a 2, that's just a 6. So that cancels out also. And at the end of the day, once I'm done canceling all this stuff out, I get 56. That is the number of different combinations you can make, choosing 5 people from a larger group of 8. If I were to go through the logic of this, like why this actually works, we could spend a day or two talking about this. I mean, it really is a very interesting topic, but for all intents and purposes, you are going to be better off if you just memorize this formula. When you get into a standardized test like the SAT, ACT, this will sometimes come up, and if you don't know the formula, you're just out of luck. So I would recommend getting to know that one, practice it a few times.